Oh, we need it to be screen 2. Nope. Yeah. That's looking like what we wanted. All right. Construct. Vanessa was kind of killing it on a bunch of binary tree problems, but haven't done many that require either modifying the tree or building the tree. Dude, I'm like sneezing too. It's crazy. That shit's spicy. Okay, so basically, paintbrush. Let me just make sure this works. La, 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 la. Eraser. Where's the eraser? Would it be like that? Yeah. Okay. Cool. Okay. Construct. Write a method construct that accepts an integer n as a parameter that constructs a new integer of n nodes numbered 0 through n minus 1. Okay. Such that an in-order traversal would be values in sequential order. The tree should be balanced. Okay, this makes sense. So, wait, the tree should be balanced in that the number of values in any node's left subtree should always be within one number of the values right subtree. If there is an extra value in the node's 2 subtrees, it should be in the right subtree. Okay, so this is like a full binary tree here. It's if you do an in-order traversal, which is where you do left, then me, then right. It'd go 0, 1, 2, 3, 4, 5, 6, right? So in-order traversal here is 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. Okay, yeah. So, cool. In-order traversal, and if there is an extra value in one of the node's 2 subtrees, it should appear in the right subtree. Okay. I need to think about this for a sec, actually. Okay, so basically I'm like, oh wow, this is interesting. So Okay, so I guess let me think for a sec. This node here, 3. At that point, we have construct 7, right? And that's going to be a full binary tree, right? So this, this here has, I guess, this has 7 nodes in this tree, right? This has 3 nodes in this tree because it's 7 divided by 2, right? And this has 1 node in the tree because it's 1 divided by 3 divided by 2, right? So like here, 4. And we're given 10. This doesn't work. Then I'm thinking the left subtree. Let me think. Well, the left subtree has 1, 2, 3, 4. 10 divided by 2. I guess, hold up. So this has 7. So this would have 7 minus 1. Or no? Wait. I'm trying to think of like if we're given the number, like if our method is given the number of nodes that needs to be in its subtree. Does that make sense? So like this one is given 7. That's how many nodes need to be in the whole subtree, which is true, right? And this one needs to be given 3. And this one needs to be given 1. This one needs to be given 1, right? So why was this one given 3? So actually, let me look at that. So seven. Yeah, I think it's because it's 7. So for this one, it'd be 7 minus 1 over 2, right? Equals 3. That's how many are in this subtree, right? How many are going to be in this subtree? Well, it's going to be 10 minus 1 over 2, which is equal to 10 minus 1 is 9, divided by 2 is 4, right? That makes sense. So, like, the method is always getting the number of nodes in its subtree. Wait, sorry. Your method should replace any existing tree. It should construct an empty tree if past the value is 0. It should generate an illegal argument. Okay, cool. So then it's like the right side is where the extra children go, right? So if we look at the right side here, how many are going to be in there? It's going to be 10 minus 1 over 2 plus 10 minus 1 mod 2, right? So, 10 minus 1 mod 2 is either 0 or 1. But 10 minus 1 is 9. Mod 2 is 1. So that's 1 plus, so there's 5 in this one, which 1, 2, 3, 4, 5. Yeah, that makes sense. Okay, so basically, what I'm passing to this is the number of nodes that's going to be in the tree, right? So this first one, we know there's 7 there, or we know there's 10 there, right? So I just came up with an equation to say, okay, let me pass to my left child the number of nodes that's going to be in that tree. And then pass to my right child the number of nodes that's going to be in that tree, etc., right? Yeah, so basically, I guess it'd be, left nodes equals n divided by 2. That's how many nodes are going to be in the left subtree. Sorry, n minus 1 divided by 2. That makes sense? Because it's like, how many are there? Well, it's the total number. Half of them are going to be in the left, half of them are going to be in the right, so that's divided by 2. But that wasn't accounting for myself. So I need to, do myself, right? And then right nodes is, I guess we could just do n divided by 2, which is the same as doing n minus 1 divided by 2 plus n mod 2. It's the same thing, right? But basically, I'm not subtracting the 1. So if this is 10, it'll be 5. If this were 9, it would be 4. So it works. It works. If it were 8, it would be 4. So like for this, let's just check if this works. All right, we're given 7. How many are on the left? It should be 7 minus 1, which is 6, divided by 2. So that's 3. So 1, 2, 3. Cool. That was correct there. And then this was given 7. So the right nodes is 7 divided by 2, which is?
3.
Yeah. So 1, 2, 3. Okay. The equations worked there, right? And then this one's given 10, right? What is left nodes going to be equal to?
What's 9? 4?
4. 1, 2, 3, 4. Yep. And then right nodes is equal to?
5.
5, which is 1, 2, 3, 4, 5. Okay, that works. So these are my equations to figure out how many nodes are going to be in this subtree, right? But I kind of want to, so to actually figure out what, to figure out what is like going on here, I kind of want to walk through this one. So basically I'm like, okay, what's going to happen is we've got 7, and I'm also going to keep track of a count. Actually, I don't even need to, let me think. 2, 3. Yeah, I'm going to keep track of like a count, which is going to be like whenever I create a node, I'm setting its value to that count, and then I'm incrementing the count. So basically like, my count will be 0 here, and then it'll be 1 here, and 2 here, and 3 here. Yeah. Cool. So, okay. So basically here, here we've got 7 and count is 0, right? So our n is equal to 7 and our count is equal to 0 right here. And then we're going to recurse here in our, n is equal to 3 and our count is equal to 0, right? The count passed in. Okay. And then we're going to be here, and we're going to say our n is equal to 1, yep. Because 3 minus 1 is 2, divided by 2 is 1. Okay. And our count is equal to 0. And then we're going to recurse left from there. Our n is going to be 0. So at that point, I'm here. So really, if n is 0, I want to return null. If n equals 0, return null. That makes sense to me. So at this point, bam, our n equaled 0. So what do we want to do? We want to say, okay, we have finished our left call and we have assigned. So this is going to be the x equals assign x, or x assign change x, right? So I'm going to say, left node equal, actually, wait. I'm going to make a little, scroll down a little bit. I'm going to write this pseudocode over here. Okay, so let's say, oh wait, no. This is going to go here. Okay. So first I did this, then I calculated the number of nodes, and I recurse left. So the recursing left needs to be done here, where I say, node, tree node left equals recurse, and I'm going to pass in my count, right? So I'll pass in left nodes, and I'm going to pass in, my n and my current count, which is, I'll call it cur. Okay. So this is what I have so far, and that's what has happened here. So we're good there. This returns. What do I want to do? That was null. So once I've done that, then I want to say, now I need to create myself, right? Because we're creating this in like a in order traversal type vibe, right? In order traversal. Okay, so basically where I'm at is, if my left one was null, then, so I'll say if left is not null, here's what I'll say. If left is not null, I want to update my count to whatever it returned. So basically if I'm here, then like, here, let me scroll up actually. If I'm here, let's say I'm at the top one, right? My count started at 0, right? Oh, fuck, this doesn't work. Wait, shit. I don't... Entry... I don't know how to do this without, like, a helper little, like, class that can keep track of the count. But I don't think you ever really need to do that in 143. Hold up, sorry. Basically, I need some, like, I would basically want, like, a global variable or something to keep track of this count, right? 0, 1, 2, 3, right? Because this, like, when this returns up here, it needs to return the node so that this can assign its left value. But it also needs to return, like,
The count.
3. Yeah, the count. 3. Or really 4,
Well,
right?
So, okay. Oh, 4?
Yeah, like, I want somewhere with, like, the kind of global count type vibe. I mean, okay. I'm going to have a class that says, do you ever have to, now I don't remember. I'm like, did you ever have to do this in
remember how to make a class.
143?
Nah.
Well, that's how I'm thinking to do it. Wait, can I think of any other way to do this?
So you're counting up to 4 right now.
Given a variable tree of type entry. All right, I'm going to say I've got my private class, and I'll call it, construct result, and it'll have a node and a count, okay? I'm just going to do that. I've got a node and a count. That's all it is. So,
Sorry, I don't want to interrupt your flow.
Yeah.
But if there's a way to solve it without the use of a class, could you? Because I think that it's simpler.
Yeah.
Than it doesn't need a class. I don't think. I think
Yeah,
it's really simple. I don't know what the solution is, but I think
Oh, man.
you need to just go from 0 to 4 and then 4 to 7.
You go from
Like
0
in
to
like a
4 and
for
4 to
loop.
7. What do you mean?
Like you're adding nodes in a for loop, and their value is 0, 1, 2, 3. And I think you just need to do
Oh.
that binary search.
Oh,
Okay.
but that would be a worse runtime, so I wouldn't even think to do that, right?
But I think that's the way that I expected to be solved.
I see. Oh, okay. Damn, I like my solution better, and I kind of want to keep going with mine. Making a class, it's 3 lines of code, right? It's just, this is the code, right? Like this is the code for the class, right? It says int count or int node and int count or whatever, right? But yeah, I suppose you could do this where you're here you're inserting
I think that is
4, and then you insert
yeah.
1, and then you insert 0, and then you're just building a binary search tree. But that is that's n log n time, whereas what I'm doing is O of n time. So I'm gonna keep running with the O of n. I'm just gonna keep running with this because it's actually not that hard to understand. The class isn't going to be like, I don't understand what's going on, right? But maybe what you should be learning here is inserting into a binary tree, I guess. So I'm missing the forest through the trees here. I'm gonna keep running this. Okay. So basically, if my left is not null, so if my left was null, we're chilling. But if my left is not null, then what I can do is say I'm going to update my count. Oh, actually, no. Instead of returning null here, I'll just return a new result with a null and the same count. New result. Okay, cool. So then here, basically no matter what, we have the count. We don't need this if statement. So this is not a tree node. This is a CR, construct result, okay? Which has not just the tree node, but also the count that we're currently at, right? So basically, this result is just a way for us to be able to return 2 values, the node and a count. Make sense? So the count was 0, and then this just returned a result with null. So this has null and count of 0, right? So our count is 0. What we want to do is say, okay, we are a new list node. I'll say tree node, I should say. Tree node, I'm just going to say me, myself, equals new tree node of count. Sorry, not count. Of left.count. Make sense? So this returned the count which had not been incremented or anything, right? Okay. And then we are going to say right equals recurse on right nodes. Sorry. Fuck. And what should we pass in to the current count for right?
It's gonna be me. It should be, well, wait. Me divided by 2? N divided by 2.
Here, wait, I'm going to say int, I'll say, my val equals left dot count equals left dot count.
Okay, so it's my val divided by 2.
Yeah. I'm going to change the name for count. I don't want this to be node and count. I'm going to call this curval. Okay? All right. So this is going to be left.curval. Okay. So in my val equals left.curval. Do we like that? Okay. So then basically what was returned from my left when we're down here, when we're looking at this one right here, what was returned from left was one of these construct results that said null and curval 0, right? So we're saying, okay, let's construct a node with the curval, right? And then we're going to eventually say, all right, my left is the left results tree node field, right? So, yeah, this is, it's actually not that confusing, but it's not like the best, kind of first x assign change x problem or something, right? Because it's not super clear what's happening here. But I'm going to keep it running, and then maybe we can do it how it was supposed to be done, even though it's worse runtime, and I wouldn't really think to even do it that way. Okay, so basically, we've got my val, bam. Okay, and then actually an easier way to understand this would be instead of doing the class, it'd just be saying, let's say I have a global variable, right?
Oh, that helps.
Yeah. I just don't do that, cause you don't do global variables, but so this is just a way around the global variable thing, but I could see that this could be a little much. Basically, if we just had a global variable called curval, this would be really easy to do. And it's not much more confusing with the class thing, but I can see it being a little confusing at least. Okay, so anyway, I'm this. Okay, cool. And then on the right, we've got the number of nodes that we're giving it, and we need to give it the current val. What is the current value?
It's my val.
So I want curval, kind of what I want curval to be, is I want curval to be, if I were creating a node, that's what I would have set the value to be. That's what curval is, right? So it was 0 when we returned here. And then we're going to recurse down here. And we want curval. My val right now is 0, right? Mm-hmm. So I actually want it to be 1. It's because it's the next value that's going to be used. You know what I mean? So I'm actually here going to say, I'll say my val plus 1, right? Okay. And then the right's going to do its thing. So let's say I'm up here. Oh my God. Let's say I'm here, right? I recursed left, and it returned this node, 1. This node is what the node field was, right? And what are we going to want the cur val field to be from this return?
Sorry, I'm a little lost. For 4?
Yeah, we're
Well, we're
here.
returning
So we
3.
just made this call.
It would be 3.
So we close. But we want cur val to be whatever the value of the next thing that's going to be
Is assigned to.
is assigned. The next value we're going to fill out, right?
So it's 4.
It's 4. Yeah. So, cool. Okay. So, awesome. So we need to make that a reality, right? So now what we're going to do is we're going to say me.left equals left.node, right? Me.right equals right.node. And then I'll say result equals new construct result, and then I'm going to say result dot node equals me, right? Does that make sense? And then result dot cur val equals something. What is it going to equal?
It's by val.
Wait a minute. I think what I was thinking to do doesn't work. My val. If I did I was going to do my val plus 1. But that actually wouldn't work because then here, my val is 3. I recurse right. I return my val plus 1. Then here it's 4. Oh, sorry. I mean right val plus 1. So then this one, the right val would be 4. Okay, wait. Okay, honestly, I think you're going to understand this solution more if we just have a global variable. Let's just have a global variable. So let's ignore the class thing, okay? Sorry about that detour. Okay, so let's say we have a global variable called cur val, right? So then we just need to figure out when we'd want to increment cur val. Well, it'll be when this is really easy now. I should have done this in the first place. So, okay. This is now tree node left equals recurse left nodes cur, right? So this is x assign change x, right? That's what it is. And we don't need this cur. Okay. And my val is always just going to be cur val.
I like that.
Okay. So we recurse on left. And then we say, what am I? I am a new tree node with curval, right? And then we recurse on right. We don't need this. Okay. Then we say me dot left equals left node, me dot right equals right node. Sorry for making that needlessly complicated. And then me dot left equals left node, me dot right equals right node, and you can also maybe just pass in an integer. Does that work? Like a capital I integer so that it's stored in the heap? That maybe works actually. Me dot left, me dot right, and then what am I doing here? So I say me dot left equals left, me dot right equals right, and then I return me, right? But what I haven't done is I haven't ever done curval plus plus, right? And where do I need to do that? I need to do that every time, like when I create a node, which is happening here. I create a node with the curval, boom, I increment it. The next time I create a node, it'll be one higher. Okay. This is now the code. It's actually... Was this on code step by step or?
This is on practice.
Okay. I wonder if it'll be on code step by step. I kind of want to, like, actually do that. Log in. Java. Binary. Wait. Trees. Binary tree. Wait.
Do building Java. Do you click the bottom one?
Oh.
Oh, well, it's in a chapter or something.
That's okay. Stat queue. Linked list. Binary tree properties. Construct.
Damn. I could,
Construct. There's no construct.
I can give you the login information.
Or I could just write it out real quick. JGrasp is not on this computer. What an L. Alright. I'm downloading JGrasp. Funnel the JDK. Yeah, we're drinking sodas. We're drinking sodas.
Drinking sodas. You're cold.
This was a train wreck. This is not a good.
You think this problem sucks?
Well, it's just hard because I think the way that it wants you to do it is like, yeah, you just like insert into the binary tree. So you'll insert 4, then you'll insert 1, then you'll insert 0, then you'll insert 2, then you'll insert 3, then you'll insert 7. You know what I mean?
Mm-hmm.
But
Is that not O of N? Also?
no, because it's like, look, you insert 4, then you insert 1, so you need a traverse. Then you insert 0, you need to traverse. Then you insert 2, you need to traverse. Then you insert 3, you need to traverse, right? The height of this tree is log base 2 of n, and for each node, you're traversing the height.
I see.
So to construct the tree that way is n log n. But the way I'm doing it is we create this node. We create this node. We create this node. We create this node. We create this node.
I love that.
We create this node. Create this node. Create this node. This node. This node. Return, return, return. Yeah, so... Okay. Install JGrasp. That's Java Grasp. JGrasp. We're about to grasp some stuff. And the debugger will be just the thing that lets us know whether or not it's working. And it'll actually do a great job of just showing us what's happening. So honestly, this is the way to do this shit anyway. You'll see. You'll all see. That's me clicking. And it not working. And now everything's frozen. Oh. My whole computer's
Did you
frozen.
that shit? It might recover it.
Yeah, I'll probably recover it. My whole computer's frozen. If you're watching the stream, can you hear me? My computer has been compromised.
Send.
We're under fucking attack. Send help. Oh, yes, please. Okay. I just had to click. I had to click. Okay, so here's the vibe. I'm opening JGrasp. And we're just gonna build this from the ground up. It'll be really easy, actually. Trust me. Skip. File, new. Java. Okay. I know how I can change the font size. Public class. View. How can I change the font size? Maybe I just zoom in and it makes everything bigger. Okay, cool. Public class. I'll say tree problems. I'll do binary. Binary tree problems. Okay? You follow me? Mm-hmm. So now I'm going to do we've got our tree node, right? What's that going to have? A value, and then left, and then right? All right, we're done with our tree node class. And our binary tree problems is going to be an instance with a tree node overall root, okay? How do we feel about that? Mm-hmm. Feel okay? I'll just make it private. Why not? Why not? Okay. Overall root, okay? So, so what I want to do is I want to say, let's have a tree. Binary tree. We're going to use the default constructor, okay? And then we're going to, what do we want to do? We want to say construct 7, right? And I'm just going to say, hooray. We did it, right? Cool. And I can write this method
going to be an instance method of the binary tree problems, right? So I'll just say public I'll say void construct, right? Because we're rewriting overall root here. It takes an int n, right? We get the vibe? Okay. So what are we doing here? Okay, I'll say if n is less than 0, throw new illegal argument exception. Cool. Otherwise, we're going to say construct helper of n. Okay. Okay. Yeah, okay. So, right now I'm just going to do this in a hacky way. And I'm going to have this global variable we were talking about. Not actually global, but it's across methods, which is busted. But I'm going to say private int curval, right? This is busted. Don't ever do this. But I'll say curval equals 0, right? And then I call construct helper, okay? So I know my curval starts at 0, okay? And then private void construct helper. And we take an int n, right? So now is where we look at what we got. So basically we're saying, oh, whoops, sorry, this returns a tree node, right? X assign change X. And then how do we feel about this? This returns a tree node, right?
Mm-hmm.
So what, we're not catching it, the return here. What are we going to want to do?
Assign it.
Assign it to what?
Overall.
Overall root equals that. Okay, cool. I'm liking this so far. What are we going to do? Oh, and then we also need, I guess we'll just pass in null at first, right? So we've got our int n. Actually, I want to, hold up. Do we need, we don't need to keep track of where we are actually in the tree. Okay, no, we're fine. We're fine. Okay, cool. So if n is equal to 0, what do we want to do? Return null. That was like we were over here. Our n was 0. We're right here.
Mm-hmm.
Bam. Okay, now we're here where our n was 1 there, right? So what we're going to say is int left nodes equals, and it was n minus 1 divided by 2, right? Int right nodes equals n divided by 2, right? And then tree node left equals recurse left nodes. Okay. And then we are making ourselves. So we do left, then me, then right, because we're doing in order traversal. So tree node me equals new tree node. And what are we going to pass in? Curval. And then what are we going to do? Actually, what we could do, what a bunch of leak coders would do is this. Curval plus plus. Whoa. But you're welcome to do this. Curval plus plus, like that, right? I'm actually just going to do it like that. So basically it's, you move left to right. So it returns the value 0 and then increments it to 1. Okay, cool. But we get what's going on there, right?
Wait, sorry, explain.
All right, never mind. let me just do this then here. Curval plus plus. Does that make
Would
sense?
have returned the node and then updated the
Not the node. I'm just talking about curval right now. I'm talking about an integer.
It would create a tree node with a value 0, and then after it created it, it would be 1. Is that what it would have happened?
Well, it's just. Let's just keep it. Let's keep it like this. Let's keep it like this. Okay. Okay. Curval plus plus. All right. And now, what do we want to do? We want to say tree node right equals. Oh, not recurse. Construct helper. Construct helper right nodes, right? And then, cool. That's basically it. We just have to say me.left equals left, me.right equals right, and then return me. So that was weird. And, you know, that's the vibe. Binary tree problems in my documents. I'll say CSE. I'll just put it in the CSE folder. Huh! New tree node. I didn't give it a thing. Class tree node. Okay, so I'll say we've got a constructor tree node that takes an int n and says this dot, sorry, I'll say val, this dot val equals val. Okay, cool. You've got that constructor. Now we don't have a default constructor, but for now, that's fine. It compiles. Okay, I want to debug this. Okay. Locals. Got overall root. Okay, so this is going to be a little hard to visualize. Where's the continue button? Is that it? Resume selected thread or thread group. Resume. Okay. So our n is 7, right? Let's go to our tree real quick. What the fuck? How did that happen? I'm going to put that out for a sec. Okay. N is 7. Ignore the count thing. Our curval is 0. How about that, huh? This curval 0. We see that. I see you. Okay. So then what do we do? Is this going to be true? No. So so we step over. What's our left node's going to be? 3. Right? No, it's 3 because I did 7. Okay. Then I'm making me. Oh, I stepped over the construct helper. Huh? Huh? That worked? To step over the construct helper? But shouldn't it have breakpointed there? So now my curval is 3, which is... What the fuck? Wait.
The picture looked right at the bottom. Look at the picture.
Yeah, but that looks great.
That's awesome.
But all right, sorry, I haven't used this debugger in a sec. My bad. Let me run it back. That's awesome. Wow, it does exactly what I want to do. That's awesome. The whole point of this is to like visualize what's going on. Okay. Bam. I'm gonna be using not step over, but just continue for the most part. And I actually want to do this with the other one because we already know this one works. So what we pass in? 10?
Mm-hmm.
Cool. Okay. So let me continue. Is n 0? No, n's 10. So I'm gonna put a breakpoint I'm only going to be hitting continue, so I'm going to be putting a breakpoint here. Breakpoint here. Breakpoint here where we recurse. And then breakpoint at what we're returning. Okay. Okay, so continuing. Bam. Okay. So here we are. Left node's 4, right node's 5. That sounds good, right?
Mm-hmm.
Look at this. 1, 2, 3, 4 trees there. I mean, nodes there. 1, 2, 3, 4, 5 nodes there. Looks good. Okay. I'm going to hit continue. And we should go back up here. And just like that we do. Okay. So now our n was 4 because we're looking right here, right? So I'm going to hit continue. Okay, construct helper. Where are we going to go now?
Oh, sorry, what?
Where are we going to go from here? When I hit continue.
You're gonna go to that other breakpoint.
Gonna go what?
To the next breakpoint. The next line.
Next,
Oh wait, no, the top. You're gonna go
top here. Okay, cool. Bam. Okay. N is 1. Is N 0? Okay. Bam. Where am I gonna go?
Top.
To the top. Okay. Bam. So now I'm actually gonna step through. We returned null. Alright. Now I'm gonna continue. We're gonna be back there. Okay. Local variable, we've got our left, right? And it finished and it returned null. So where are we in this tree? What is me about to be?
We are the 1. Zero. 3.
Shit.
So what's the state of the world? What's the state of the world? This just finished for the first time. Construct helper.
Okay.
And what did it return? Because this recursive call finished, right?
Uh-huh.
And then we assigned it in something called left.
Mm-hmm.
What is left? It's null. It's null. That's null. Left is null.
Oh.
Sorry. Oh,
Just
yeah.
like overall root. Oh, yes! Sound like an actor. Oh, yes! You see that left is null, right? Just like overall root is null, okay? Right? Okay. So where are we?
Where are we?
What is me?
Me?
Yeah. What is me about to be after this line executes?
Curval. Where curval is 4. It should be 4. Ah, fuck.
I'm going to click this.
No.
Okay, this call just finished for the first time. Right? I mean, so our call stack is a bunch of those. It was this, it was this, it was this. You know, we started in main, and then we went to construct, then construct helper, construct helper, construct helper. Right?
So,
Construct helper just finished for the first time. Where are we in the tree that we're wanting to build when that thing finishes for the first time?
0.
We're here?
Yeah.
You sure?
Yup.
All right. Absolutely, right? Okay. So me is going to be a tree node with value 0. That's me. Okay. And I could assign my left right now, but I'm not going to. I can just do it later. That's fine. Okay. Curval plus plus. Boom. Curval. I spoiled it. Boom. Curval is now 1. It was 0. Now it's 1, right? Okay. So, what do we do now?
Go to the right.
We go to the right. Okay. I'm going to hit continue, not step over. Continue. We're here. What is N?
0.
0. Yeah. So it's just going to return. All right. So now we have that left is null and right is null and me is 0. So boom. We assign those. It's a little redundant. And we return me. Boom. We are off. Okay. What call? We were just in construct helper. What call just finished? Actually, here.
So we have 0.
Left is 0, right?
All right.
So what is me about to be?
1.
1. Me is 1. Curval is currently what? 1. What's it about to be?
2.
2. All right, now we recurse to the right. Okay?
Yup.
This is going to be interesting. This is going to be interesting. Okay? Because we're recursing over to here, right? So it's going to be like a null there, but then a not null there, right? It's going to be interesting, right? So let's run it. Let's run it. Okay, here. Is this going to be true?
Nope.
Okay, it's not. So left nodes is 0, right nodes is 1. Think about that. So what's going to happen when we call this on the left side? It's going to return null. It's not going to do any incrementing of curval or anything. It's just going to return null. So bam. Sure enough, it returned null. Okay. So that returned null. Now what do? We create me, right? Blue one is where we're at. We create me. What is me going to be?
2.
2. Me. 2. Right? Right. Then we do the right side, but right nodes was 1, right? So that's actually not going to return null. It's going to go, and it's going to recurse left, and then it's going to return, and then it's going to make me, which is 3, then it's going to recurse right. And now it has left is null, right is null, me is 3. It assigns those, returns itself. Boom, look at that.
This visualization is awesome. This is so good.
So we're at here. We're at the 2, right? And it said 3. 3 is my right child, right? And then we're saying, cool, we did X assign change X. This is a little indirect. It's more like, here's change X, now assign it to X, right? It's not like, we didn't do me.right equals this here. We could have. I just didn't. I could have done that. All right. But we couldn't have done it with the left one, though, so it's a little tricky. This isn't the best X assign change X example. Okay. So we just create this finished. We assigned this. Bam. And now we're going to return 2, right? So what is our tree about to look like? Boom, right?
Yup.
Because when we click this, we're going to be here. You know what? I'm going to add breakpoints to here and here. Okay? When I click this, boom. Look at that. Me is 1. Remember? Remember when we were here? That's where we are now. Me is 1. The left was 0, and the right is looking like this. So me.left, are you excited for this?
Yeah.
Look at this. Me.left,
Well,
look at that. Left points there.
I like the way it's even on the left.
Right is going to point there. Look at this. Boom.
Whoa.
Huh?
Whoa.
How do you like that? And then I return myself. Where were we before? What was the first thing we did when we got into this bitch? We weren't really in 4 yet. We didn't know 4. 4 is something to be... We were just in left here. This is where we were, remember? Right? So when I call this, that just finished. Left is now equal to that. Does that make sense? So now we say, what is me? I'm just curval, right? Curval is 4. Me is 4. I rest my case. Right? We can see this. It'll look beautiful. We can do it a bunch. We can get those leaf nodes done. Look at this. Bam!
Sick.
7, 8, 9?
7.
That's why 6 was afraid of 7. Look at that. Okay, so now look, we're at the top. And this is a thing of beauty, right? This is how we think about things from the first person. We were at the top. We did left, and that's what it returned. We made ourselves, and then we did our right, right? And now we just assign a couple things. Left, right, and return. Our overall root equals that. Would you look at that?
That's really nice.
I rest my case. Okay. Hooray. We did it. So, that was not a very good learning lesson, I don't think. It was just like not good. But I can't even think to do the n log n solution because I'm like, dude, why do n log n when you could just do O of n? One thing I am wondering though is could I not do this with the curval thing and can I say like integer n, hold up, and then integer class Java, integer, get integer, no, static classes, int, hashcode, min, max. I'm like wondering if you can just do this by like having an integer, like, I mean like obviously you could do this sort of thing by like
And like
passing an array with one value. You know what I mean?
like passing by reference, but with it.
Yeah. I'm like,
Oh, interesting.
how can you do that?
And
Pass
C#
int.
is a ref keyword. You just.
I know, by reference Java. How to pass an integer by reference in Java. Integer. That's so ugly.
Is it?
Oh, a mutable int class. Atomic. Oh, wait, using atomic integer. Built-in Java class that provides a single-threaded environment. All right, I'll do that. Fuck it. That's how we'll do it. Because I actually like that more than this having a field garbage. We're going to pass in the atomic integer,
Whoa.
which is a concurrency thing.
Whoa.
So I'll say atomic int. Oh, whoops. Construct. The public method did not take this. Okay, so here we would pass in atomic integer curval. Atomic integer Java. So this should also work. Add and get. Increment. So is there an increment? Get and increment. Automatically increments.
Oh, this is so.
Yeah. Increment and get.
Whoa.
So we want to get and increment. We don't want to increment and get. So literally what we're going to do here is we have our atomic integer, curval, and then here we say new tree node of curval dot get and increment, right? It's actually pretty straightforward. And then here we just pass in new atomic integer. Curval, get out of here. Construct helper. Curval. Right nodes. Curval. So that is actually the goated way to do this. And really, there's no other way. Did it work? I don't know. Probably did. Debug. You'll learn more about like what atomic is and what is thread safety and all that when you're learning about parallelism and concurrency. Anyway, let me just click continue. What's our guy look like?
What does he look like?
Yeah, it worked.
That's sick.
Yeah.
That's so sick.
Dude, just the little freaking get and increment method.
I love it.
Tight. Alright. That's not how it was supposed to be done in the class. Whoops. That would have been